Okay, so this is another long project, long in the making. And the rough idea is to see if we can understand debt management behavior, so the portfolio of bonds issued by the government, in a standard Ramsey flexible price full commitment model. Okay, so if we would like to see if a Ramsey model can get somewhere close to the issuance of long and short or whatever bonds government issue. And that's the project. Don't ask me if it's a normative or a positive paper because I have no idea, nor do I care. The idea is to see how close a model, okay, how close we can get. Now, this is nice to present in front of. So there's these two papers by Angeletto, Sguera, and Nicolini, which we will call ABN. So it's nice to present this in front of the N. They wrote two papers where what they did is just have a long and a short bond, or have a number of bonds, but the number of bonds was the same as the number of possible shocks that could occur. Like you all know, in that case, you can complete the markets, so you can achieve optimal allocations, okay? But the interest was then to see what were the positions, or what were the bond issuance that would give rise to the optimal taxes. And what they found is that in a fairly generic way, the optimal portfolio meant the government issuing long bonds, actually issuing a lot of long bonds, issuing very huge positions. So I guess for reasonable calibrations, you could find government should issue 500 or 600% of GDP in long bonds. And then because the total debt should be whatever it should be, then to compensate, the government had to purchase a lot of short bonds so that the net debt would be roughly 60% of GDP or whatever it was in the beginning. Is that clear? Now, the reason that long bonds were so good is that the interest, roughly speaking, the interest rate of long bonds is negatively correlated with primary deficit. So it kind of provides an automatic insurance. If you issue long bonds, you pay less interest in bad times. And in exchange, you pay more interest in good times, but that's okay. That's the way to insure. Is that clear? More or less. So these were these papers. And while we were working on debt management already, we saw these papers and we said, well, but this is going to be easy to kill, you know. I mean, this is ridiculous, no? And it took 15 years or so, but we you know, these two things, what this is saying, perhaps it's giving a message, you know, that long bonds are good, but it's so far from the data that you think, well, there must be something else that is missing out, and it might be interesting to see what's missing out. It could be that, you know, it's easy. One easy way to overturn this is that the government is not behaving optimally, the government is lazy or crazy. But, you know, if we model consumers, if we model my aunt as a consumer as being optimizing something, why should the government be minimizing or something? No, it's so as a first pass, we wanted to pursue the idea of how could we, if we could get somewhere closer to the data to observe that management within the framework of Ramsey policy. And like I said, it wasn't so easy. So we want to get away from these two things, or see if it was possible. Now, what you see, as you all know, governments not only don't issue huge amounts of any bond, and I usually said, and they never purchase private securities, of course, after the financial crisis. I can't say that anymore, but I can say that they don't do it for insurance purposes, right? The government bought a lot of private stuff for other reasons, okay? So let's ignore that. Usually, the government issues long bonds and short bonds. You see these all over the world. We have data from many countries. You always see a sizable share of the bonds are in less than 1 year bonds. This is the share for the US of short bonds we would call under a year over total debt. And well, it's been fluctuating, but it doesn't have a huge variance, okay? And it's never close to zero. Lowest is 27%, something like that. And well, it's decreased. This is what you see in the data. It's very different from what ABN showed and different from other papers I'm going to mention. So the share is sizable. Positions are not large multiples of GDP. The first order serial correlation of this share is 0.96, is very persistent. And the standard deviation is very low, is 0.5%. Okay? And the portfolio shares are never negative. And then there are a few other facts that we emphasized in a paper with Andrew Scott, which is that if markets are effectively complete, that has the same persistence as output. Okay, you can show that in many models. That if markets are complete, that is just adjusting up and down to output or to deficit fluctuations. But what you see in the data, of course, is that that is much more persistent, is very, very persistent. And you wouldn't get that in a model of complete markets. And what you see, and I don't have time to explain it here, but you can see the paper if you want. Under complete markets, debt and deficit are negatively correlated. Basically, when you have a bad shock, you get a big payment. Okay? Under complete markets, that's what would happen if you effectively complete the markets. That's not what you see. And here in this paper, we argued that, well, we showed that introducing incomplete markets would get that as in the data in these two basic features. That would be very persistent, and that would co-move positively with the deficit. Okay, so the project will be to introduce market incompleteness. Okay, so introduce frictions, introduce fewer financial assets. That's the project. Now, these two papers already did some of this. What they basically did is just impose a non-negativity constraint on bond issuance. So you could call it a no lending model. The government cannot lend to the private sector. You just impose that. You could justify that in many ways. Governments actually try not to do this. They did it, okay, the last few years, but they try not to do it. You can imagine lots of reasons why governments don't think it as a good idea to hold stocks or something. They impose these constraints, and what they find is they solve part of the issue. Yeah?
Besides the financial crisis, some governments actually do lend.
Yes.
The sovereign funds.
Yeah.
Not that many, but
yes.
sovereign funds they do.
Yes.
Or
Okay.
public firms. The ownership directly of public firms.
So they own public firms, but we've seen that governments try to get rid of those, and there are good reasons why they do. There's the pension issue, but that's an asymmetry in the long run. Yeah. So they would, but for other reasons that in your paper. So it's not for insurance. It's kind of a dangerous way to insure, to hold. I would say most governments would see it as a dangerous way to insure to buy stocks of a firm. No? Which firm do we buy? Okay. So what they do is just impose non-negativity constraint on all bond issuances. And what they find is that, okay, then they find reasonable positions, but they find that the only thing you issue is long bonds, okay? So if you put that non-negativity constraint, so the intuition from ABN still comes back at you and is driving the result, okay? You get as close as you can to ABN, but given the constraint, you cannot issue short bonds, but you only issue long bonds. Short bonds are 0, all right? So still ABN is coming back as close as possible. So this is not what you see in the data. In the data you see short bonds, and then what we will try to do is to see what is the minimal, if you want, or what is a very simple way, what is the simplest way we can come up with so that short bonds are a good thing to issue. Okay?
What's the proportion in the data?
It was in that picture.
Oh, okay. Well, short respect.
Less than 1 year.
Yeah.
Short is less than 1 year. Yeah? Respect to total debt. So we will keep the standard models, and so what you can think of, if you've seen the literature, what we're doing is we're taking this paper where we had incomplete markets and putting a second bond, a long bond, in addition to the short bond that we had in here. So there will be a long and a short bond and many possible values of the shock, so governments cannot effectively insure, and then we'll introduce other frictions. So what you could call is you could say we introduce true market incompleteness because the government cannot insure now. So we'll consider lots of various things. We will start with a model of buyback, where, as is standard in the literature, every period, all the old long bonds that were issued are immediately repurchased. Okay, that's the standard. I'll go into this. We'll start with us. Then we'll go to a model of where government is forbidden from buying back. We will just impose that if the government issues a long bond, it has to stay in the private hands until it matures. Okay, we'll just fix that. Then we'll put limits, then we'll introduce coupons, and then we'll introduce some form of callable bonds. I'll be going into this.
So in the consumer side, you have one consumer?
We'll do everything as close as possible to the standard model.
There is no secondary market for these long bonds?
There is a secondary market, but it's the same market as always. It's just there is no secondary market among private agents. No. Okay. So what we will find is that just introducing the no buyback assumption, no buyback restriction, works. If you would issue only long bonds in a model with incomplete markets, what happens is that if there is a shock and you only issue long bonds, 10-year bonds, then in 10 years you have a lot of refinancing and a lot of interest payments. And then in 20 years you do, and in the middle you can't do anything because you only issue long bonds, right? And so if you only would issue long bonds, you would have these cycles which are not good for smoothing. And short bonds will be good because they fill in the holes. That's if you have to leave, that's the paper. All right.
The no lending is important there too, then.
The no lending.
Use the lending to offset the
Yeah.
cycle.
So the no lending in short bonds is important, but because you could have a lot of short lending, but you would have kind of like a Ponzi scheme in short lending, which at some point so even if you would put the limit on short bonds is not 0, but it's you can lend up to a limit. you cannot, you need a lot of short bonds to be able to undo these holes. But that's a good point. Yeah.
You mean that equilibrium depends on the distribution of long bonds depending on the age or issue? Or?
Yes, yes. Everything will be there.
You may have an equilibrium where it was uniformly distributed across time, then there is no such a cycle.
You could, but the shocks will be happening and they will have an effect. And you cannot insure them. So you will not, at any point in time, you can have a huge shock to government spending and you have to swallow it because you cannot insure against it. So you could have, it will not be an equilibrium that you have a constant amount of bonds because you will have to use debt whenever you have a shock because there's nothing else you can do but to increase the debt. Yeah? So that's, okay. So this is a standard model, flexible prices, full information, full commitment, etc. All of these things would be interesting to relax. We don't. The government maximizes the utility of the agent, and then, well, this feasibility, this is leisure, T minus X is hours worked, linear utility in labor. And the only thing we do is instead of having this one bond that is repaid, it was issued last year, it was being repaid now, and it is purchased, well, sold by the government at a discount. In addition, there is this long bond, and to begin with, the long bond, which is also bought at a discount, is also, we begin with the buyback case, the standard case, where the government buys back all the 10-year bonds that were issued last year, all of them are bought back today. And then new 10-year bonds are reissued. All right? This is the standard assumption, is what ABN does. It's also what Lustig, et al. And Nosbusch assumed. Okay? Now, well, these are the first of the conditions, it doesn't matter. What matters, perhaps, is to realize that in a model like this, you have a very large state space. Even with incomplete markets, even when you have buyback, all of the bonds that you have issued matter for full commitment solution. The way you commit to future taxes for the next n periods matters for today's bond price, and therefore you have to keep track of all the bonds that you have issued and all the promises you have made to lower taxes to influence interest rates. So anyway, for the equilibrium is that the...
So at this one, here you can issue any maturity.
No, you just issue one maturity, which we say is n.
Only one.
Yeah. Yeah. 10 years. Oh. So applying recursive contracts, which at least my students know how to do, I don't know if anybody else does. You can show that the optimal solution under complete market, the solution under incomplete markets with perfect commitment is a function of today's shock, of course, and of the n period bonds issued in the last n years, and the last n lags of the Lagrange multiplier, because the Lagrange multiplier of the budget constraint of the government is entering here with an n period lag in the first order condition. Okay, so you have that's the difficulty. Okay, you have a very large state space, and linear approximations are not going to work very well. Okay, look in here. These terms tell you that the state variables lambda and b enter in a nonlinear way. At least you need a quadratic approximation to capture that term. But also the limits are going to play a role, right? The landing limits are going to play a role. So any linear approximation or even linear quadratic, any perturbation method could miss out a lot on these things. So we want to not do that, not do perturbation methods. State space is large, 22 state variables for a very simple model, extremely simple model. So, well, this we do. Okay, then we do. So I have. When did I start? 25 minutes. Okay. So we do two numerical tricks that kind of solve the numerical issues. One is we do what we call condensed parameterized expectations, which does the following. Under parameterized expectations, what you do is you take this conditional expectation which appeared in the first order condition of optimality. Okay? If I go back, there's this first order condition of optimality, which is a key condition on optimal bond allocation. And there is this expectation of the marginal utility that enters. And there are other expectations that enter. And parameterized expectations, you assume that this, well, you take this as a time invariant function of the state variables. And then, okay, we need all these state variables, but it's unlikely that all of them will be extremely important all the time in the steady state solution, right? If you want an example, if we would be under complete markets, we wouldn't need all the bonds. It would be enough to know all the wealth, right? So the wealth is enough. Now, here the wealth will not be enough, but probably not all the 22 variables. You need to keep track of all of them. So the idea is to summarize all of those 22 variables into a few variables that matter for the solution. And you can do that in the following way. Just choose a few state variables. We call it the core variables, 2 or 3. And I think it's G, 1 log of B, and 1 log of lambda or something like that. Okay? Choose a subset of state variables. Solve the model, quote unquote, solve the model when the expectations depend only on those 3 or 4 variables. Okay? Now the solution, because you do PEA, the solution doesn't only depend, because the solution, you know, consumption will depend on n logs of lambda. The solution you get depends on all the logs, okay? It's just that this thing here, only this thing is now in a first step depending on 2 or 3 variables, all right? You get a solution, which is not a good solution in principle. You get the first approximation, and then you check of all the remaining variables, what is the best linear combination that predicts this, what the function should be predicting. Okay, and you get a linear combination that is the best one predicting that. And if we would find that the best linear combination doesn't predict anything, we would be done, right? We would say, well, these other variables don't matter, so I have a approximate. But if it does, what you do is you take this one linear combination and you add it as one more state variable. And so this is a convenient way of taking 22 variables and adding giving all of them a chance, giving all of them a chance to do something in the solution. And then this linear combination picks out the ones that have the best chance.
Are you trying out all of the linear combinations of all of the 22? That's the idea?
Yeah, but you can do that in one step, because you do a linear regression. Well, you do it's not a regression, it's a projection if you want. You do a long simulation, you regress. You have a simulation of this, you regress it. It's not a regression, but you run it as a regression. You regress it on all the variables, and you have in one step, in 1 millisecond, the best linear combination. You could do that with squares and cubes and other powers to introduce any nonlinearity you want.
But this is given the, sorry, I'm just trying to,
No.
so this is given the sufficient statistics, and these can change, right? So what I mean
Right.
is you have to find
So you do, so exactly, so you do you do this until you don't need. So you do one linear approximation, then you solve it again with this one state variable, and then you run another regression until and then you maybe get a different linear combination, and you keep doing this until you don't get any better approximation. But yeah, you need to put more linear approximation. Alessandro, I think.
Just a question. Could you do the same using principal components, for instance? You have.
We kind of do principal components. In the sense that we don't really do this regression. We orthogonalize everything so that the regression is well behaved. So yeah, we kind of do it like that. Yeah. So there are some details that I skipped, but.
You claim that you will get cycles of say order n, yeah? And why you don't take the t minus n?
We do. Actually, I think we put that in the core, but when we do the regression, lambda t minus n is in here, and it will show up in this regression if lambda t minus 3 matters. It should show up. Is that clear? Well, we can talk about. So this is the idea, and this is why this is possible to solve. There's another issue because there are really here two agents, government and consumer. It's still now for a long time people have tried, but it's difficult to have two similar consumers, to simulate models with incomplete markets with two similar consumers. Like Juan Carlos and Dirk and people have done a huge amount of progress, but it's usually different agents. You have if you have the agents that are quite different. They've made a lot of progress, but these two agents are similar. The consumer and the government have the same objective function, okay? And then the way the shocks impact on their budget constraints is different. But they are sufficiently similar, and then the way you would do parameterized expectations generates singularity. I don't have time to do it in detail, but I'm going to skip this, okay? There is a way that now is working out very well for simulating models with parameterized expectations when you have two similar agents. Okay, parametrization, we follow what we did in this other paper. No, it's a very simple, it's extremely simple, okay? Log utility, this utility from labor has a wage elasticity approximately of a half, which is supposed to be a first order approximation. This gives 1 over x here. Government spending is an AR1 process, which in mean is 25% of output, and very persistent. Okay, so then the first model we look is literally like Angeletto's Guerra Nicolini, so with buyback and without limits to lending, okay? But with this G process, which means that governments cannot complete the markets. And this is the simulation. The black dashed is the behavior of long bond, the blue is the behavior of short bond. So ABN comes back again, okay? They want to issue a lot of long bonds, quite a lot of short bonds. You don't get huge multiples, but quite large positions. You get a negative correlation of the long and short bonds, and that's because you can think of this model as ABN, but instead of the wealth being constant because markets have been completed, is like ABN, very close to ABN, but where the wealth goes up and down because the shocks cannot be fully insured. Okay, so it's like kind of here, from here to here, it looks very much like ABN, but in here is like with a different initial wealth, and in here than in here. Then what happens is that the discounted sum of profits is very well approximated by a small constant plus a constant times the government spending. So when you have a high wealth, shocks matter more for the variability of the discounted sum. Okay. So basically what happens is you not only need to move the level of long and short bonds when the wealth is higher or lower, you need to make them also more different because the variance of the discounted sum is also bigger. Okay? So you get this negative correlation, you get still the basic message, long bonds are good, but you get this negative correlation. And you look at the data, so these are the three moments I gave you, mean, standard deviation, serial correlation of the share. You look at the at the correlation of the market value of short bonds over GDP. You need to do trend, otherwise they would be positively correlated because of the trend. So market value of short bonds over GDP, correlation with market value of long bonds over GDP, it is positively correlated. We kind of know this, no? When there's more debt, government issues more of everything. Okay? And in the model I just showed you, this negative correlation, which is very different from the data. Okay? This is what the model does. Very high variance of the short position. And is it intuitive, more or less, why that is the solution coming out? First model. Then second model we look at is a model with the non-negativity constraints, no lending model. Can be seen. Nosbush had a 3-period model, so what we do is what he did, but multi-period. Okay, this second model. Or Lustig et al. Is very close, but they had nominal rigidities, nominal bonds, and a few other things. Okay, so we don't have those nominal rigidities in this paper. This is the second model we look at. So now we add the no lending constraint. Okay. What you can see is that, well, again, the model kind of wants to be like in the previous model, right? So you still have this negative correlation. It cannot be completely negative because once you hit zero and you're stuck, right? And then you have to go away. But when you are away from the constraints, well, you can see sometimes there is a negative correlation, and sometimes they have to go in the same way, but not perfectly. So this is the model with buyback, no lending. Buyback, no lending. Now, like in Lustig, Nosbush, now the size is reasonable, all right? Well, okay. They had I take that back. Lustig, Nosbush, they had a 0 in here. Okay? We don't have a 0 because in some periods debt is sufficiently high so that you also want to have short debt. But, well, the average is low. The standard deviation is very high. The correlation is almost 0 because in some periods it was positive, some periods it was negative. And serial correlation is not very high. So this gets closer but not too close. Okay. You can see here in the model the short bond is 0 10% of the times. In the data you never see 0 short issuance. All right. So we go to the no buyback model. So how to justify this? Whenever I say we look at the no buyback model, people are used to having buyback. They know it's easier if you have buyback. They want to recover it, right? No, and some people say, no, but you know, governments do repurchase. Governments do repurchase bonds sometimes. And they say, and governments have issued callable bonds where governments can recall the bond. And there are even papers written about this, but these are, you know, very big exceptions. the reason people are interested in this is because it doesn't happen very often. If you would have anywhere close to repurchase, like in the models, gross issuance of debt would be 100%. In the real world, it's not close to 100%. Gross issuance of debt, so how much bonds the government issues each period, is this as a percentage of debt. Is never anywhere close to, is never bigger than 60%, more like 40%. Nowhere close to 100. And if you look at the repurchases of non-callable bonds, there are whole papers written about events or countries that repurchased bonds, okay? But this is how much it was. 93% of the long bonds, non-callable bonds, were left to mature. All right, so as a first order approximation, it seems, assuming no buyback is what happens, and that's what we do. And no buyback is going to matter once we have incomplete markets, okay? Just to, if you have complete markets, all that matters is what is the discounted value of payoffs that an asset will give you. But under incomplete markets, the timing of the payment matters a lot. So for the government, issuing a long bond that's bought back is just a bond that next period gives you an uncertain return. So it gives you a return in one period. But a bond that is left to mature gives you a certain payment in 10 years. It's very different from the point of view of incomplete markets. Okay? So it's going to matter. And this is what happens when you have, okay, and so just to give intuition for what I explained at the beginning. So what will happen if you leave the bonds to mature? Then this is the budget constraint, right? It's now you sell these bonds, the government sells these bonds, but it has to pay back the bonds that it issued N years ago. Now if you do the discounted sum of the budget constraint, it has this form. You don't add overall, the wealth or the debt is not equal to the primary surpluses in the future. It's only equal to the primary surpluses every N years, because nothing else is in here. The primary surplus is in between. You cannot do anything with the bonds, okay? So you have this discounted sum where J runs from 0 to infinity, but this is times N, okay? So it's only the primary surpluses every 10 years that matter. Now, because of this, then imagine a case where G0, so this is just as an example, a case where G0 is bigger than all the other Gs, and this is no uncertainty, but you have to issue only long bonds, 0 coupon long bonds. What would the tax be? Well, the black line is how taxes would have to be if you only issue long bonds. You cannot do anything else, no? You have a bad G, you have to issue debt. It would be stupid not to issue debt, but you can only pay it every 10 years. And that doesn't look like tax smoothing at all, right? If you issued short bonds, you would have the blue line, which is optimal tax smoothing in this case. So the short bonds will play the role of filling in these holes. Now in the real world, in the model, there will be lots of shocks every period, and in the model, lots of things will be happening. But this is the basic intuition. Is that clear? Okay. So the model. So when we simulate the model, this is what happens. Short and long bonds move together. And the moments that we get, these are the old ones with buyback. The ones that we get are very close to the data, except the size of the share. Now there are too many short bonds. We could do lots of things. We didn't even try to choose the parameter in any way. We could do lots of things to bring this down. Sorry?
Some buyback with some limits, maybe that's more
You could do lots of things because the governments do a lot of other things actually. Yeah, yeah. But we didn't. We stopped.
If you
Yeah.
have short 10 and 30 years, it's naturally going to lower the share.
For example, that could, it could, and that would, yeah. There's lots of things. You could put inflation index. In practice nowadays, debt management is very complicated and very sophisticated. So there's lots of other things they do. So we didn't try. But what we think is striking, no? This correlation was, very far. We do t-statistics just to be formal about whether this is close or not close. We could argue. These are the t-statistics. So this is the actual sample moment minus the model sample moment divided by the standard deviation that you would get from a standard statistical asymptotic analysis of standard deviations. So it's not dividing by the standard deviation of the model, which is a problem because if you divide by the standard deviation of the model, then two wrongs could make a right. Having a very bad model with a very bad standard deviation could make the t-statistics look very good. And so we do the standard deviation is from the data only. And well, this is bad. No buyback gets much better. And then we also introduce a model with coupons where the coupon is determined by every period the government promises the coupon that gives today a bond that's sold at par so that the price is 1. Okay? It's like the payoff. And it's even better. So that's basically the point. We also do callable bonds, but just very shortly. So another thing that happens in seminars is to say, people, no, but there have been callable bonds, okay? And yes, they have. This is the share of callable bonds over long bonds in the US. And they were substantial at some point. But they have not been issued anymore since 1983 or 84. So that's why the stock has been dwindling.
Substantial is 0.5% or 50%?
Say that again? This is 50%, yeah.
This is 50%.
50%, yeah, it was
So
big.
callable bonds are what? That you
So
can
then
at some
callable bonds are that they issue a 10-year bond, but then there's a call window where some years before maturity, the government can tell you, no, now you have to sell the bond back to me.
At what price?
At a pre-specified price. Okay? So it's kind of buying, the government
It's an
was,
option of the government, right? Option may
the
or may
government,
not do it.
of the government, yeah. So it's insurance for the government for interest rates going down. Okay? And it's insurance, but the insurance goes at a price. And
Right.
for some reason, I don't know why, that management office in the US decided it wasn't worth paying this price anymore.
'Cause
But
also
okay.
interest rates went down.
Yeah, well, probably, I don't know.
Then the,
I could speculate why they did that, but I honestly don't know. I honestly don't know. Now, what you observe is, well, first, these things have been disappearing. Second, what you observe is, I don't think I have a picture here, but we have a picture in the paper where almost 80% of these bonds were bought at the beginning of the call window. So this option is exercised almost all the time as early as possible, first. But as early as possible is almost always more than 10 years. Okay, so we have a table with all the bond issuances and what was the maturity and the call windows. You can check, you can show in the paper. Almost all the call windows are okay, so all the 10-year bonds, all the 10-year bond issues, the call window was 2 years. So they had to stay in the private hands for at least 8 years. And then they were mostly recalled at 8 years. So anyway, this complicated thing we model it as follows. We say we issue 10-year bonds, but they can be recalled after 5 years. And instead of a pre-specified strike price, we put the secondary market price at 5 years. And basically nothing changes. So putting in, there's lots of things you could do with callable bonds. You could design them optimally. You could do lots of things. But when you look at actual practice with these, it has been very simple. And if you put this in the model, it behaves very similar. Yeah?
So nothing changes because you put the secondary market on the calling back price, or also if you would have put a fixed price, also nothing would change.
So we haven't checked that. We got tired of trying models. Honestly, we have many things, and we haven't checked that. But basically, the intuition is now there are these holes. They are 5 year. The holes are 5 years, and you still need the short bonds, just like you did with 10-year bonds. So anyway, this is the collection of results. Okay.